Hello everyone. This is the third worksheet of chapter 12, which is on two population proportions. Chapter 12 is on population proportions. In the first two sections of this chapter, we covered one population proportions, and the last section is on two population proportions. So we're going to first work through this example, which I'm going to go through pretty fast because I've already discussed this in my lecture PowerPoint slides. I worked this out there completely, so you may already have seen it, but I'm going to just work this out quickly before I go to another problem on this topic. Okay, so here it says eating out vegetarian. Zogby International surveyed 1,181 US adults to gauge the demand for vegetarian meals in restaurants. The study polled independent random samples of 747 men and 434 women. Of those sampled, 276 men and 195 women said they sometimes order a vegetarian dish when they eat out. We want to use the data to decide whether the percentage of men ordering vegetarian is smaller than that of women. So we're going to perform a hypothesis test. Now, they haven't told us at what significance level we should be performing the test. So I'm going to just give you a significance percentage, the commonly used significance percentage, which is 5%. So I'm going to say here use the 5% significance level. All right. So first we have to go ahead and extract our data from the question. So we first have to know what n is. So let's go back to the question and reread it. It says Zogby International surveyed 1,181 US adults. So they were sampled for the question whether they order vegetarian dish when they eat out. So the total number of people who were in the sample, who were sent the survey, was 1,181, and that's our n, 1181. So I'm going to write n for 1181. Then we have to find what N1 is. Now keep in mind, when we are working with two populations, we first have to define the two populations in the sense that we have to first decide which group we are going to put under population 1 and which group we are going to put under population 2. Now these are independent samples, these are not paired. So, and the two populations are men and women because we are comparing the habits of men and women if they order a vegetarian dish. All right. Therefore, one population, I'm going to just assign population 1 to men and population 2 to women. All right. So, since men have been assigned population 1, N1 is also going to be the sample size of men. All right. So let's try to find out from the question, what is the sample size for men? It says here the study polled independent random samples of 747 men. And that's going to be our N1. So I'm going to write here 747. All right. Let me spread out this number here. I think 1181. 747 was the sample size of men, N1, and N2, which is going to be the sample size of women, would be 434. All right, it's 434. Now, next, we have to find P hat sub 1. That means the sample proportion of men who responded yes to the question that they order a vegetarian dish when they eat out once in a while. All right. So again, the formula for the sample proportion, keep in mind, is going to be x sub 1 divided by n sub 1. So x sub 1 will represent the proportion or the number of men who responded yes. All right. So it's going to be, how many men replied yes? 276. So 276 men met the specified attribute. So 276 over 747, it's going to be a value which is 0.369. All right, so 0.369. That's p hat sub 1. P hat sub 2 is the proportion of women who responded yes to the question, all right, who met the specified attribute. So that's going to be x sub 2 divided by n sub 2. X sub 2, that means the number of women who responded yes is 195. So it's 195 over n2 is 434. So when you do this division, we'll come up with a proportion which is 0.449. 0.449. Now let me tell you that in statistics, if they don't specify the decimal places, by default, please write up to 3 decimal places. All right, 3 decimal places, that's the default in statistics. Don't make it 2 until unless the question asks you to. All right, always show your value, your answer to 3 decimal places. So that's why I've left it at 0.449, even though I could have rounded up to 0.45, but I'm not going to, because that by default we use the decimal place as 3, the 1000th decimal. The next question says, or the next part of the question says, check assumption. So it has to be SRS, which it is, all right? And then it has to be independent samples, which here it says independent. And the other one is that x sub 1, all right, x sub 1 and n sub 1 minus x sub 1 should be greater or equal to 5, and likewise x sub 2 and n2 minus x sub 2 should also be greater or equal to 5. Therefore, all the assumptions are met. So you can just quickly show in your assignment or on the test when they ask you to check assumptions, put in a value. X sub 1 is 276. Of course, that is greater than 5. Similarly, n sub 1 minus x sub 1, this will be 471. Then x sub 2 is 195, and 434 minus 195 is going to be 239. All right, and so all are greater or equal to 5. That's a no-brainer. So we met all the assumptions. We can go ahead with our hypothesis test. What's the null hypothesis? Null hypothesis. Now we are comparing proportions. So you have to write it as P1. P sub 1 is equal to P sub 2. Null hypothesis will always say that they are the same. There's no difference between men and women ordering vegetarian dish when they eat out. All right. So again, you are comparing 2 proportions. You have to write it as P1 equals P2. Don't put a numerical value next to the equal sign when stating the null hypothesis for 2 population proportions or 2 population means, whatever it may be. For the alternate hypothesis, it's going to be H sub A colon, and then we are going to have a P1 on the left-hand side and P2 on the other side, but whether we are going to put a not equal to or less than or greater than, for that we have to go back to the question, reread it. Let's see what it says. If we want to use the data to decide whether the percentage of men ordering vegetarian is smaller than that of women. That means we are trying to determine if men, the proportion of men order vegetarian fewer times, less frequently than women. So we are going to use the less than symbol, all right, for the alternate hypothesis. And whenever there's a less than symbol in the alternate hypothesis, it becomes a left tail test, right? It becomes a left tail test. Step 2 is to determine the significance level. We have decided to use the 5% significance level, so we are going to write it as alpha equals 0.05. Again, alpha is a decimal value between 0 and 1. All right, it represents area under the curve. So it has to be written in decimal form and not as 5%. Alpha is not 5%. The significance level is 5%. Next, it says draw a diagram showing rejection and non-rejection regions based on alpha. Let's quickly do that. It just asks for a diagram. It doesn't ask us to find the rejection. It doesn't ask us to find critical value and all that. Now, it's a left tail test. Keep in mind here, it's a left tail test. So our reject region is going to be to the left. So let's write that. Reject to the left and do not reject to the right. And this area under the curve that corresponds to the reject region is alpha equals 0.05. Correct? Therefore, the cutoff between the reject and do not reject, which is a z value, all proportions based questions will use z distribution. All right? So it's the z tables that we are going to refer to. Now, because it's a left tail test, the cutoff z value is going to be negative z of alpha, which is 0.05. So I already know z of 0.05 is 1.645. So I'm going to just write it down anyway, although they didn't ask us at this point. It's going to be negative 1.645. Negative 1.645. So here's our diagram. The next step is to calculate the test statistic. All right, so let's look at the formula here. Again, this is z that we are trying to find. It's going to be z sub 0. So it says p sub 1 minus p sub 2 divided by square root over p hat sub p times 1 minus p hat sub p, and then again square root over 1 divided by n1 plus 1 divided by n2. Now here it says p hat sub p in the denominator. So that means it is a pooled proportion. All right. So here's a formula for the pooled proportion. So before we can work out this z value test statistic, before we can plug in the values, we do need to find p hat sub p. Otherwise, we won't have a value to plug in the denominator. All right. So let's do that. P hat sub p, it's a very easy formula. X sub 1 plus x sub 2 divided by n sub 1 plus n sub 2. So I'm going to write that here. P hat sub p is x sub 1 was 276 plus x sub 2 was 195. Divided by n sub 1 is 747 plus 434, which should be equal to the to n, the total sample size. So the denominator will be 1181, and 276 plus 195 is going to be 471. All right, 6 plus 5, okay, 471. So p hat sub p, when you do this division, should give us a value of 0.399. Again, 3 decimal places. Now that we have a value for p hat sub p, let's plug in the values here in the formula to find z sub 0. Z sub 0 is going to be p hat sub 1, which we found here, right? 0.369. So for the numerator, we are using the p hat sub 1 and the p hat sub 2 values. So it's going to be 0.369 minus p hat sub p was 0.449 divided by square root over p hat sub p is 0.399, so 0.399 times 1 minus 0.399 times square root. Now you can put this under the same square root, all right? I don't know why they split it, but let's just use whatever formula has been given to us. So 1 divided by n sub 1 was 747 plus 1 divided by 434. All right, now I would first calculate the numerator, write it down, then find the value for the denominator, write it down, and then do the final division and get the value. But like I said, I need to move through this fast because I already worked out this problem in the lecture PowerPoint slide. All right, so z sub 0 is going to be negative 2.726. So that's our test statistic value. That's our test statistic value, negative 2.726. So now we are going to go and start using these approaches to come to a decision. For the critical value, let's draw the same curve that we drew above to define the reject and do not reject regions. It's going to be on the left-hand side, the reject region, reject. And the other side is going to be do not reject. Let's shade the area for the reject region. It's alpha equals 0.05. And here's the cutoff. So we said the critical value is going to be negative z of 0.05, which comes out to negative 1.645. So our critical value, the CV, okay, critical value is negative z of 0.05, which from the table appears to be negative 1.645. And now let's bring our test statistic value, which is negative 2.726. Just a second, let me just... All right, so negatives... Okay, so z sub 0 of negative 2.726, negative, all right? It falls, it's less than negative 1.645. That means it will be to the left of negative 1.645. So negative 2.726, all right? So negative 2.726 is less than negative 1.645. It falls way, way to the left, all right? So if we extend this, it'll be way to the left somewhere, which is the reject region, negative 2.726. All right, show that value on the diagram as well, where the z test statistic falls. And then right here, falls in the reject region. The reject region. All right, so our decision is going to be, therefore, reject null hypothesis. That's going to be our decision, but let's work this out using the p-value approach and see if it leads to the same decision. So for the p-value approach, we start with the test statistic value. So I'm going to draw a diagram here showing on the curve where negative 2.726 is going to be. Like we said, it's going to fall to the extreme left. It's a very, very low z-score, so it probably will be somewhere way to the left. All right. Actually, let me just redraw this picture because we are bumping into the critical value approach region, right? So here we go. Here's our normal curve, and here you don't need to show your reject, do not reject. That's only for the critical value approach. All you do is show your test statistic, the z value. Let's say it's somewhere here, and it's negative 2.726. Now, because it's a left-tailed test, the p-value is going to be the area to the left of negative 2.726. All right, so this area is going to be the p-value. Just because it's a left-tailed test, it's the area to the left of the test statistic on our diagram. Okay, so you have to look up your table, or you can use your graphing calculators or whatever tools you use to find your p-values. You refer to the table. So let's, just a second. Okay, here we are back again. So just refer to your table or your graphing calculator. I used my calculator to find the exact p-value, and that's going to be a value of a very, very low value. All right, but let me write down what needs to be done to find the p-value. All right, so find area to the left of the test statistic value z sub 0 of negative 2.726. All right, so we are finding the area to the left of negative 2.726, which is the p-value. All right, so the p-value is 0.0032. All right, it's a very small value, so we can clearly see that it's going to be less than alpha, right? So that was the first step to find the p-value. Step 2 is to compare p with alpha. All right, so p is 0.003. Is it less than 0.05? Okay, so we are checking if it is less than 0.05. Yes, correct. As 0.05, keep in mind, is our alpha value. Yes, therefore reject null hypothesis. All right, again, using both our approaches, we come to the same result, same decision. So the decision is going to be, that step 5 is going to be reject null hypothesis. And of course, we have to put in our interpretation, which is going to be at the 5% significance level. At the 5% significance level, let's separate this significance level. The data do provide, all right? So if it is reject, then you say the data is strong enough the evidence is strong enough to reject the null hypothesis. So the data do provide sufficient evidence to conclude that. I'm going to go back to the question to pick up the verbiage again. It says whether the percentage of men ordering vegetarian is smaller than that of women. All right, so I'm going to write to conclude that the percentage, because it said percentage in the question, I'm going to use the word percentage and not proportions. All right, I want to answer the question exactly as they asked. So that the percentage of men ordering a vegetarian dish when eating out is smaller than that of women. Smaller than that of women. All right? So that's the complete hypothesis test for this problem. Okay, and then does it say, ask us to find the confidence interval? No, it doesn't. So I'm going to just leave it at that. And then there's another question in this worksheet. Just a second again. Now we shall work out another problem on comparing two proportions. Now this problem is not an application-based word problem. Instead, here we have the data given to us and we don't need to extract the data points from the verbiage of the question and all that. They have given us all the information out here. They've even told us what kind of test it's going to be. They've told us the alpha value. They've given us the confidence interval value percentage as well. So we just have to use these values to set up the problem and answer the questions. All right. So here it says x sub 1 is 10. So that means the population 1 sample that responded yes is 10. N sub 1, that's the population size of population 1, the sample size of population 1, I'm sorry. Sample size of population 1 is 20. X sub 2, that means the success frequency, success number from population 2 is 18. For the sample size for population 2 is 30. Alpha is 0.10. That means they're asking us to test this at a 10% significance level, make it a left tail test, and then when we go to find the confidence interval, make sure you're using the 80% confidence interval. All right, so the first step is to find the sample proportions. Again, this is about two proportions, therefore we will need to find two sample proportions. All right, so p hat sub 1 is going to go with the formula x sub 1 divided by n sub 1. X sub 1 is given to us as 10 and n sub 1 is 20. So it's going to be 0.5 for p hat sub 1. All right. For p hat sub 2, it's going to be x sub 2 divided by n sub 2. X sub 2 is given to us as 18. N sub 2 is 30. So 18 divided by 30 is 0.6. 0.6. So these two are our sample proportions from population 1, or sample proportions from the sample drawn from population 1, and again the next one is for samples drawn from population 2. Now we might as well also find p hat sub p, because that's going to figure in our equation when we go to find the test statistic. So we might as well find it here. It's a very simple formula: x sub 1 plus x sub 2 divided by n sub 1 plus n sub 2. So x sub 1 plus x sub 2 is what? 10 plus 18, right? 10 plus 18, these numerator values. And then n sub 1 plus n sub 2 is going to be 20. How much is it? 20 plus 30, right? So that would be 50. So it's going to be 28 divided by 50, which would give us a p hat sub p value of 0.56. Now this pooled proportion is going to be used in the denominator of the z statistic formula. All right, we will need to use that. Now decide whether using the two proportion z test is appropriate. Let's assume it's SRS, simple random samples. Let's assume it's independent. But for the third one, we have to look at the data and make sure that x sub 1 and n sub 1 minus x sub 1 And on the other hand, x sub 2 and n sub 2 minus x sub 2 are all greater or equal to 5. All right. So yes, x sub 1 is 10 and n1 is 20. 20 minus 10 is also greater than 5. So this is going to be 10. This is going to be 10, which is greater than 5. And x sub 2 is 18, right? And n sub 2 is 30, so 30 minus 18 is 12, so n2 minus x sub 2 is 12. So all of them are greater or equal to 5. So all conditions are met. All conditions met. All right. Now we can go ahead and start on working through the hypothesis test. The null and alternate hypothesis need to be stated. H sub 0 colon P1 equals P2. Please make sure you're not writing P hat sub 1 and P hat sub 2. We always state the hypothesis using the population symbols. The population proportion is to be written. All right. So make sure there's no hat in our statements. Alternate hypothesis H sub A colon. Now this, they said here it's a left tail test. So if it's a left tail test, then P sub 1 is less than P sub 2. That would be a left tail test. All right. How do I know? Again, it's a left tail test because it's told us in the question itself. Make it a left tail test. All right. Then step 2 says determine the significance level alpha you are testing at. They gave us an alpha value of 0.10. So don't always assume that it's going to be 0.05. That's the alpha we have been using for most of the questions, but it can be different as well. So in this case, alpha is 0.10. Let's quickly draw a diagram showing the rejection and do not rejection regions. So reject region is going to be to the left, being a left tail test. The other side is DNR, and this area under the curve corresponding to the reject region is 0.10. So we need to find a z value. All right, so it's going to be negative z of 0.10. All right, negative because the z value is located on the left hand side of the midpoint 0 of the center point, right? And we will come up with a a critical value of negative 1.281 if you look at the table, look up the table. Okay, so now we can go to step 3, which is applying this formula and coming up with a z sub 0 value. Now, we already calculated previously that p hat sub p has a value of 0.56, right? It was 0.56. We did the work before, but you can show the work here as well if you wish. All right, here's the work. Remember, p hat sub p is 0.56. Now let's plug in the values into the formula. P hat sub 1 was 0.5 and p hat sub 2 was 0.6. Here are the values. All right, so you have to look up to or look back to part A where we calculated the sample proportion and pick up the values from there. So p hat sub 1 is 0.5. So z sub 0 equals 0.5 minus 0.6 over square root over 0.56 times 1 minus 0.56 times square root over 1 divided by 20 plus 1 divided by, this is a plus, divided by 30. So z sub 0 calculates to, just a second, negative 0.10 divided by Now 0.56 times 1 minus 0.56 is 0.44. So we have in the denominator square root over 0.56 times 0.44. And then under the other square root, we have 1 divided by 20 plus 1 divided by 30 should give us 0.083 for a z sub 0 value of negative 0.709. All right. We will now perform the test using the critical value approach first, and then we'll go on to the p-value approach. Now for the critical value approach, we first have to draw our curve to show the reject and the do not reject regions. So here's our curve, and this being a left tail test, our reject region is going to be to the left of the curve. So here's our reject region, and then we have the do not reject region on the other side. And the area associated with the reject region, the area under the curve, is alpha equals 0.10, right? Now, the critical value is, which is also the cutoff between the reject region and the do not reject region, is going to be minus z of alpha, which is 0.10. All right. Now, when we refer to our table, it's going to be a value which is negative 1.281. So let's write our value, the exact value of the critical value, the cutoff value, negative 1.281. All right. So let me write it down here. CV equals negative z of 0.10, which from our table comes up as negative 1.281. Now that we have defined our regions, we have to bring our test statistic value, which is z sub 0. What was it up here? Let's see, it was negative 0.709. So z sub 0 of negative 0.709, I'm sorry, 709 is greater than negative 1.281. So it'll fall somewhere to the right of the cutoff value of the critical value. So maybe somewhere negative 0.709 is close to negative 1. So let's just mark it somewhere here. Okay, definitely to the left of the midpoint of this curve. So let's write it as negative 7.09, which is clearly the do not reject region, correct? So we have to say here falls in the do not reject region, and therefore the decision is going to be do not reject null hypothesis. So that's with the critical value approach. Let's see if we arrive at the same decision using the p-value approach. For the p-value approach, we first again draw our curve, but this time there's no reject or do not reject region that we need to show. We have to just bring our test statistic value, and our test statistic value was z sub 0 equals negative 0.709. All right, so we have to show that on our curve. All right, again, it'll be somewhere here, maybe. Let's mark it here. Negative 0.709. And I'm going to extend a line from that point up to the curve, and the area to the left of that value of our z sub 0 value on the curve is going to be our p value. It's area to the left because This is a left tail test. If it were a right tail test, then you would take your test statistic would most likely fall on the right hand side, and you would take the area to the right to find the p-value. So when I refer to my table or from the graphing calculator, I was able to find the p-value of the p-value is 0.2419. This area here is 0.2419. That's the p-value. So once we have the p-value, so let me just write what we did here for you to understand. Find area to left of z sub 0 equals negative 0.709, and that's the p-value of 0.2419. So in the second step, this was the first step. In the second step of the p-value approach, we compare p with alpha. All right, is p less than alpha? That's what we are looking for to reject the null hypothesis. So we see a p-value is 0.2419, which is greater than 0.10. I'm sorry, it's 0.10 is our alpha. All right, for this particular problem, alpha is 0.10, so we have to compare it with that. Is greater, therefore do not reject null hypothesis. Do not reject null hypothesis. So when p is greater than 0.10, greater than alpha, in other words, if p is greater than alpha, then we do not reject null hypothesis. Only if p is less or equal to alpha, we will reject null hypothesis. So the decision is do not reject null hypothesis. That was step 5. And then the final step is step 6, to interpret the test. Interpretation is, again, you start with your significance level. At the 10% significance level, again, significance level is always in percentage. Alpha, however, is in decimal. All right. So at the 10% significance level, the data do not provide. So if it is a do not reject decision, then the data is not strong enough to reject the null hypothesis. And we have to say the data do not provide sufficient evidence to conclude that proportion 1, all right, P1 is less than P2. Now, this is not an application-based problem, so we cannot interpret it in context of the problem. Therefore, we just have to use our alternate hypothesis, which was that P1 is less than P2, and our data was not strong enough, was not sufficient to conclude that P1 is less than P2 in order to reject the null hypothesis. All right. The next part is to perform a confidence interval, or rather to come up with an 80% confidence interval. So let's go on to working that out. So the question on the confidence interval says, use the two proportion z-test procedure to find the 80% confidence interval. And this is a formula to use. So let's start working on it. We know our p hat sub 1s and p hat sub 2s. And that's pretty much what we need, except that we need to use the z of alpha by 2. That's the only one that we need to find from the 80% confidence interval. So let's start working on it. Just a second. The confidence interval, all right, we need to find alpha by 2. And once we have alpha by 2, we will know how to find the z value from the table, correct? So CI is 80%. If confidence interval is 80%, then confidence level is 0.10, because confidence level is, I'm sorry, let's start this again, all right? All right, I need to restart it again, excuse me. Confidence interval is 80%. Confidence level is the decimal version of the confidence interval, which is 0.80. Alpha is 1 minus CL, which is 1 minus 0.8. So it'll come up to, hold on one second, alpha equals 1 minus 0.80. So that's going to be 0.20. And alpha by 2 is 0.20 divided by 2 will give us 0.10. Going ahead of myself here. 0.20 divided by 2 is 0.10, and that's our alpha by 2. Therefore, z of alpha by 2 is actually z of 0.10, which we found previously as 1.281. All right, 1.281. Now, z of 0.10 will be a positive value because the way we interpret this notation is the z value whose area to the right is 0.10. All right, this particular notation, which is z sub alpha by 2, whenever you have the alpha as a subscript of z or t or any other distribution, that means it's looking for the z value whose area to the right is 0.10. And when that happens, the z value or the t value or any other statistic value is going to be a positive value. Okay, so it's 1.281. So we can just go ahead and plug in values into this formula. P hat sub 1 was 0.5, if you recall. So I'm going to write it as 0.5. P hat sub 2 was 0.6, so minus 0.6 plus minus z of alpha by 2. This is z of alpha by 2, z of 0.10. So that's plus minus 1.281, then multiplied by the square root of p hat sub 1 is 0.5 times 1 minus 0.5 plus p hat sub 2 is 0.6 multiplied by 1 minus 0.6, right? So 0.5 minus 0.6 is negative 0.1, right? 0.10, let's put it that way, plus minus 1.281, and then under this radical we have 0.5. Now 1 minus 0.5 is 0.5, and when we multiply the two 0.5, we should come up with 0.25. All right, plus 0.6, and then 1 minus 0.6 is 0.4, so that's 0.4, so it's going to be 0.24. All right, 6 4s are 24, so 0.24. And then when we complete this, we will get a margin of error 1.281 times the square root over 0.49 is going to be 0.183. And then now we add, this is a margin of error, by the way. 0.183 is our margin of error, which we add and subtract to minus 0.10, and we come up with a confidence interval which extends from negative 0.28 to 0.083. All right, so this is the CI calculation. This is all CI calculation. Now, let's look at the confidence interval. Of course, we have to interpret it. Let's do that first. Let's do the interpretation first. The way we interpret it is we start with our confidence interval. So we can be 80% confident that the difference, right? We are again talking about difference. We are comparing two proportions. The difference in the two population proportions, when you are interpreting it, make sure you use the word population, or you are suggesting that it's the population that you are talking about. In the two population proportion, the difference in the two population proportions will be contained in the interval, and you have to state your interval. Contained in the interval between negative 0.28 to 0.083. Now, let's analyze this a little further. We see that this confidence interval of differences has a negative sign for the lower end and a positive sign for the upper end. That means this interval contains a zero, a difference of zero. And when the difference is a zero, that means there's no difference between the two. All right. When do we get a difference of zero between two numbers? When the numbers are same, correct? So therefore, the conclusion is that there's no difference. All right. So we can say that since zero, or rather, I'm going to be more explicit and say since the difference of zero lies in the interval, there is no difference in the proportions. In the proportions, they are almost the same. And that agrees with what we found in our hypothesis test, right? That do not reject the null hypothesis. The null hypothesis was stating that the two proportions are equal, and that's what we came up also. We kind of verified with our confidence interval as well. All right, so there's no difference in the proportion. That verifies the decision from the hypothesis test. That verifies the decision from the hypothesis test. All right, so that's how you're going to work out these kind of problems in comparing two proportions from the hypothesis test. All right.